Some learnings from this we had. Some real challenges we had when developing this system was that it was very hard to evaluate this system. So when evaluating the system, of course, you often get very different outcomes. It's very hard to get the same outcome. And then if you get relatively the same outcome, it's still hard to decide whether you're evaluating a single agent, whether this agent is doing its task properly, or actually evaluating the whole system, which will make the challenge of evaluating even harder. These challenges are also caused by the lack of explainability, why they are saying stuff, and also the lack of repeatability. Another challenge that we had was the state management of agents. So I think in the Cloudflare talk we also had the NCPs that now had the states attached to it. That would be super valuable in this situation. So basically the challenges are the same with normal LLMs, which might have tools connected to them, but then bigger. But then it becomes even harder, because now we're moving to true multi-agent systems. And what are we seeing as truly multi-agent systems? So this can be a network of autonomous agents working together. And these autonomous agents are trained to communicate and coordinate. And they don't have a predefined orchestration. So in the previous example we saw that we were really calling the different fields in order. They were not yet fully responding to each other, and that was an orchestrator. But if we want to move to a multi-agent, true multi-agent system, we need to also be able to make decisions independently. So what if we want these agents to be publicly available in an undefined private? Well, this is where the A2A, agent-to-agent protocol, comes in. So the agent-to-agent protocol has been launched by Google, I think about 1 or 2 months ago, and allows agent-to-agent communication over HTTP. Well, this sounds pretty familiar. It sounds a lot like the MCP, but where's the difference? We'll get into this later. But here, they really let agents communicate with some standards, so it's secure by default, it builds on the existing standards, supports long-running tasks, we'll also get into that later, and it supports multimodality, so the agents should be able to communicate in audio, video, images, and of course text. And now I would like to envision this virtual tumor board, but then with the agent-to-agent framework. So we had these different agents, so for instance the cell therapy agent or the genetic agent. We can also imagine that currently they might be in the same system, controlled by a single framework, but what if these would be controlled by the different departments within the hospital, or even different hospitals altogether, or maybe just different companies. And this would allow the agents to really be restricted and operate on their own knowledge bases. It's also easier to maintain the state, so you can really have the system on an isolated server running and get requests in there, so the state is fully isolated. And they can be specifically trained to excel in their own field. So it's easier than with NCP to really call a different LLM. So it can, for instance, be fine-tuned on more the data for the immune agent. So how does this work? I will show a little bit of code, extra code in a bit, and I'm pretty sure people in the back also won't be able to see this, but it works with first the agent discovery. So you program some agent cards. So this would be the reimbursement agent with a description. So this agent handles the reimbursement process for the employees, and this gets broadcast to actually the agents you are calling. So this is the agent card. This would, for instance, be provided via the well-known URI, so that's a well-known agent.json. You could also do this in just more curated registries, so inside a company, or really privately connect to different agents. They did really learn from MCP to move towards the enterprise-ready features directly out of the box. So it works over TLS. Authentication according to modern standards, so no payload identity, common authentication methods, OAuth, all that stuff. And it uses, you can simply use like existing frameworks for tracing, observability, and monitoring due to the reliance on the standard HTTP protocol. And then it is also designed to handle tasks that do not immediately complete. I think we're all experiencing right now that in the beginning the streaming was slow, but now if you're even doing tool calling, those tools might go wrong. It might get in a loop for a little bit until it figured it out. Agents can take a long time, and the system needs to be designed for this. So they implemented streaming with server-sent events for this, for incremental results, so that's when streaming implemented. And for very long running tasks, they implemented push notifications. And they even indicate that this will allow a connection to go, well, it can be disconnected, but a task to go for days. And they put this in the docs. MCP love A2A. If you read something about the agent-to-agent protocol, they often quickly start, so what's the difference with MCP? And then they say MCP love A2A. So the main difference is that MCP is really for doing communication with the tools themselves. So there is no extra LLM there, it's just doing the tool calling, so for instance to a vector database. But agent-to-agent is really for communication between agents themselves. So this is what Google also markets it to be. But we have to stay critical, so it's also interesting to say, all right, but what if one of those MCP calls is actually just a call to a different agent? Doesn't that just replace the agent-to-agent protocol? And then they also list their partners in this venture, and Anthropic isn't in there. So we're holding tight that maybe Anthropic is coming with something. So yeah, I took this screenshot from the meetup. You've seen the MCP hype. Well, you might have seen some A2A type, and now let's get some real understanding and see some real world examples. I quickly spun up the example